So let us start another theory class. In this theory class today I am going to discuss the last part of antiprotozoal drugs, anti-amebiasis, anti-giardiasis. In addition to that, we are going to discuss the drug used against the ectoparasite called ectoparasiticides. So we are going to cover this part. This ectoparasite is just not included in the anti-protozoal drugs. So this is a separate chapter. So let us start the drug against the Giardia amebiasis. So first one is the anti-giardiasis drug. So first we have to define. So name is telling the drug that are used to check the growth of Giardia or control the Giardia or eradicate the Giardia is called anti-giardiasis drugs. About the Giardia, Giardia is a flagellate protozoa and anaerobic. And because the Giardia protozoa is going to produce infection in man and animal, particular the dogs and cats, so this is important. As usually this protozoa primarily found in the lumen of the GI tract and it produces the symptoms like diarrhea. So when the diarrhea is there, then weight loss, lethargy and nausea will occur. And this is also important because of the genetic importance. The disease giardiasis is a genetic importance. Let us classify the anti-giardial drug or anti-giardiasis drugs. The first one is the nitroimidazole, that is also called 5-nitroimidazole, and the examples are metronidazole and metronidazole analog, that is ornidazole and tinidazole. The second one is the benzimidazoles, under which the example are mainly the albendazole and fenbendazole. Next one is the nitrofurance, under only one drug is there, furazolidone. Fourth one is the acridine derivative, under which the drugs are quinacrine and quinacrine also known as mepacrine. Actually, this quinacrine is an anti-malaria drug. And the last one is the thiazole derivative, and the example is nitazoxanide. Amongst these all the classification, the most important is nitroimidazole and nitrofurans, as well as the acridine dye. So we are going to discuss one by one. Let us start the nitroimidazoles. So what is important about nitroimidazoles? Nitroimidazole is used to treat amebiasis, which is, and also used to treat giardia, that is giardiasis, trichomoniasis. So main therapeutic use of metronidazole, that is nitroimidazole, is a drug for giardiasis, amebiasis, trichomoniasis. In addition to this, antiprotozoal against giardia, entamoeba histolytica and trichomonas in human being as well as the animal, also used for only minute activity against the babesiasis and histomonas. So the metronidazole is showing also activity against the Babesia and Histomonas. And in addition to the antiprotozoal activity, metronidazole also possessing antibacterial activity, particularly against the anaerobic bacteria. So this is very, very important. So as an antibacterial agent, metronidazole may be used alone and in combination with the other antibacterial agent through oral as well as the intravenous administration. So this is about the utility of metronidazole. Now we have to discuss more about nitromidazole. So in this the drug is metronidazole. So this metronidazole is possessing activity against the protozoa that we have already mentioned, and also anaerobic bacteria that we already discussed in the usage. This metronidazole is coming in the form of hydrochloride salt, and this hydrochloride salt is very much soluble in the water. Now the important about the mechanism of action, how the drug act against the susceptible protozoa. So metronidazole act against the susceptible protozoa which form cytotoxic metabolite. This metronidazole bind to DNA of the parasite, and after binding with the DNA of the susceptible parasite, the parasite DNA lost its helical structure as well as DNA strand breakage. And because of the property of metronidazole to bind with the DNA, loss of helical structure of DNA strand breakage, the DNA will not act as a template for RNA, and therefore it inhibits finally the synthesis of DNA and RNA. And as we know, by multiplying DNA and from DNA to DNA and DNA to RNA, it will leads to growth. I mean, through cell division, it will multiply the protozoa. So this is the mechanism of action of the metronidazole. Simply, it is bind to the protozoal DNA, and therefore the DNA helical structure get lost, strand get break, and the DNA template has not to be used. DNA has not to be used to synthesis of DNA and RNA, and therefore this act as a antiprotozoal activity. Regarding a species sensitive to metronidazole that we have mentioned, that is Giardia, Trichomonas, then also the amoeba, particularly int amoeba histolytica, some of the protozoa like the Babesia and Histomonas, and anaerobic bacteria. In anaerobic bacteria, what are the bacteria that are very, very important bacteria? Bacteroides fragilis. As we know, Bacteroides fragilis is usually going to produce the supra infection. So for that we have to use this metronidazole. Then Fusobacterium species, then anaerobic bacteria Clostridia perfringens, then the bacteria which produce acidity is the Helicobacter pylori, and also the against the anaerobic streptococci. So this is the activity of metronidazole against the anaerobic bacteria. Now we have to go about the pharmacokinetic of the metronidazole. Metronidazole is a lipophilic and well absorbed orally, and the absorption is about varied from 50 to 100%. Metronidazole adverse effect is concerned, as we know, at high dosage, metronidazole is going to produce the neurological disturbances. Under the neurological disturbances, the symptom like tremors, ataxia, weakness, nystagmus, and seizures are found. And because the metronidazole, as per the mechanism as we know, it will bind to DNA, and therefore it will affect the DNA synthesis that we have already seen under the mechanism of action. And therefore, because of its activity to bind with the DNA and affect the DNA synthesis, it will leads to teratogenic, carcinogenic, and the mutagenic effect. And because of this activity, metronidazole should be prohibited to use in food producing animal. And we are not going to insert metronidazole in the animals which are hypersensitive to the metronidazole, and also not have to give to those animal which is debilitated, pregnant, and nursing animal. So these are the things that we have to keep in mind while using the metronidazole. Regarding its dose is concerned, for giardia and trichomonas is concerned, for dog and cat, it is about 20 mg per kg orally or subcut once daily for 8 days, whereas for the amebiasis, which is about quite three times of the dose of the giardiasis and trichomoniasis, that is the dose for dogs amebiasis is 60 mg per kg body weight orally once daily for 5 days, whereas for anaerobic infection, the dose for the dog is 25 to 50 mg per kg orally twice daily, and for horse somewhat less, 15 to 25 mg per kg orally 4 times daily. So this is all about the metronidazole. Next drug is the tinidazole. Tinidazole is also having the same type of activity against the species. So this one is also act against the protozoa giardia and trichomonas, as well as Entamoeba histolytica, and also against the some anaerobic infection that mentioned in the metronidazole. Regarding the dose for the dog of is concerned, tinidazole dose is 44 mg per kg orally 3 times, whereas for the horse it is about 15 mg per kg orally twice daily. So this is all about the nitroimidazoles. Next is the benzimidazole. So as we know, benzimidazole group is mainly used as an anthelmintic, but the some drugs like albendazole and fenbendazole both are also used as to some extent anti-protozoal activity. And regarding mechanism of action on the protozoa is concerned, that is giardia, so it is same to the anthelmintic activity, that is it inhibit the polymerization of the microtubule polymerization by binding with the beta tubulin, and in addition it also poses the its effect to inhibit some of the enzyme which is participating in the energy generation system. So this is the mechanism of action of the albendazole, that is similar to the activity against the anthelmintic. Regarding its main constituent which produce the giardiasis activity is its metabolite. So albendazole active metabolite, which is albendazole sulfoxide, albendazole sulfone, which is possessing usually the giardiasis anti-giardiasis activity. And in when we are comparing both albendazole and fenbendazole, albendazole is the teratogenic, particularly in first trimester of pregnancy, so we are not going to give this drug. And the dose for the giardiasis in a species dog is 25 mg per kg orally twice daily for 3 days, whereas fenbendazole again the same for the giardiasis in dog, and the dog treatment is dose is 50 mg per kg orally twice daily for 3 days. So this is all about the benzimidazole. Next is the nitrofurance, and the example is furazolidone. So this drug is not much in use because of its toxicity, because of its toxic effect like GI disturbance, neural effect, and loss of weight. The drug furazolidone is mainly used as a anti-giardiasis drug, particularly for species cats, and giardiasis dose for cats is 4 mg per kg orally twice daily for 10 days. So this is about the furazolidine that belongs to the nitrofuran. Next is the acridine derivative. Under the acridine derivative, the drug is quinacrine, that is also called mepacrine. And as we earlier mentioned, this is mainly the anti-malarial drug, but this drug is also possessing the activity against Giardia, Coccidia, and Plasmodium, and this is broad spectrum activity. Primarily, this quinacrine is used. This is important point, so you have to recall it. Quinacrine we have to use for those Giardia which Giardia is resistant to metronidazole. That means ki the giardia on which metronidazole is not active, that is called metronidazole resistant giardia. For that, we have to use this anti-malarial drug quinacrine, and as well as we have to insert this quinacrine in those patients the patient is sensitive to metronidazole. So this is about the quinacrine. Regarding its mechanism of action is concerned, this is also quite similar to metronidazole, that is the intercalate, or you can say the bind with the DNA of the susceptible protozoa. So the drug quinacrine is going to intercalate to the DNA, and this drug is having both route of administration oral and parenteral, and possessing less in toxicity, less in use because of its toxicity. And regarding its dose is concerned, in puppies is total dose 50 mg orally twice daily for 6 days. For a small dog and a large dog, the dose is vary. For a small dog, the dose is 100 mg per kg body weight, thrice daily on day first, followed by twice daily up to 6 days. Whereas for large size, the dose is 200 mg per kg orally, thrice for first day, and thereafter twice daily for 6 days. So this is all about the anti-giardiasis drug. So here I am going to mention the one group that we call nitroimidazole, under which the metronidazole and metronidazole analog, that is the ornidazole and tinidazole. These drugs are very important because this drug is not only used for the giardia, but it also acts against the trichomonas and amebiasis. So this drug also coming in the anti-amebiasis drug. So now we are going to discuss the next group is the anti-amebiasis drug. So the definition for anti-amebiasis means the drug that are used to kill or inhibit the growth of int amoeba histolytica is called anti-amebiasis drug. And that, as we know, when the food is raw, whether it is or if the water is there or food is there, then and that this is raw without cook, then you will find the amoeba, int-amoeba histolytica, and this may be transmitted. Regarding its presence is concerned, it is found both in the intestine tissue and the and the other tissue of the body, as well as it also found in the mainly the lumen of the intestine. So on that basis, the anti-amebiasis drug is classified, that is that those that are acting in the lumen, so we are calling it the luminally acting anti-amebiasis drug, and those that are acting on tissue, intamoeba histolytical present in the tissue. It may be the tissue, liver, lungs, kidney, and it may be in the intestinal tissue. So this is called the drug for the tissue anti-amebiasis drug. So first one is the luminally acting anti-amebiasis drug, under which the very important group is amides. Under amides, the drug is diloxanide furoate. So when you go through the many antidiarrheal preparation, you may found one of the constituent that is diloxanide furoate. So diloxanide furoate is belongs to amide group and used for entamoeba histolytica, particularly present in the lumen. And the next group is the hydroxyquinolines. So 8 hydroxyquinolines, only two drugs is there, idoquinol and cleoquinol. So this drug is also important as a anti-amebiasis drug, particularly in the lumen. And this third group is the antibiotics. Under the antibiotics, the very important drug is the tetracycline group drugs. This may be one of the drug that belongs to tetracycline, And next one is the aminoglycoside, that is the permomycin. Permomycin is also used to treat the amebiasis of present in the lumen of the GI tract. And the two main group that is left, the arsenicals and quinone. Both the drug are not very much in use. Under the arsenicals, the example is glycobiosol, and under the quinone, the example is Fen Theon. So this is all about the anti-amebiasis drug, particularly for the luminal one. And then the tissue amebiasis. This tissue amebiasis is again divided for the tissue of the intestine and for other than intestine. So extra-intestinal or intestinal anti-amebiasis drug, under which the very important that we already discussed under the anti-giardial drug, that is the nitroimidazole, under which the drug is metronidazole as well as the metronidazole analog like tinidazole and ornidazole. So this metronidazole particularly belongs to nitroimidazole group, is to be used for both Entamoeba histolytica as well as the giardia, as well as the trichomonas, as well as the babesia, as well as histomonas and anaerobic bacteria. So this is very important. And from the same group, the second one is the emetine, that we are using as a emetics and dihydroemetics. So under the alkaloid emetine and dihydroemetine, we may have to use as a drug, anti amebiasis drug of for the Entamoeba histolytica present in the intestine or extra-intestinal. For the extra-intestinal amebiasis, the drug is chloroquine. So this is all about the anti-emesis drug. Now we have to go through the this is all about the amebiasis. Now we have to go through the ectoparasiticides. So now first we have to define what is ectoparasiticide. So as the name is telling, what is the meaning of ectoparasiticides? Ectoparasiticides simply, when we want to define is ectoparasiticides are the drug that are used to control the ectoparasite or eradicate the ectoparasiticide, that ectoparasites like the insect pest, that is called ectoparasites. That ectoparasites are lice, mites, flies, ticks, fleas, mange. So these are drugs that are used for these ectoparasites. This ectoparasite usually you have to find on the body surface of the animal, and this ectoparasite possessing very characteristic property as a vector of the disease. That means the disease, some of the disease may be transmitted for both man and animal. So therefore this become very important, like babesia, like thalaria. So this is very important. Now we have to classify the ectoparasiticides. So ectoparasiticide is classified based upon the chemical structure, chemical nature. So the first one is the organochlorine, second one is the organophosphorus insecticide, third one is the carbamate insecticide, fourth one is the pyrethroid insecticide, then macrocyclic lactones that we already discussed, then chloronicotinil, or that is also called neonicotinoid insecticide, then formamidines, then insect growth modifier, then natural insecticide, and the last one is the insect attractor. So in that, those we are going to discuss that are very important under the ectoparasiticides. So first we have to discuss the organochlorine insecticide. Under the organochlorine insecticide, this this is divided into three groups, that is DDT group, that is also called chlorinated ethane, also called diphenyl aliphatic compound, under which the examples are DDT itself and methoxychlore. So methoxychlore is still we are using methoxychlore. The second one is the chlorinated cyclodienes, that we are not going to discuss in detail because these part are also to be detail about the compound we already discussed in the toxicology class. So we are not going to discuss in detail, but we have to see the example. This second group, chlorinated cyclodienes, are we are generally not going to use because of its toxicity, because of its neurotoxicity with the dieldrine and endrine. So this group is not to use as a ectoparasiticides. Next and third and the last one is the aryl hydrocarbon. In this, only one drug, that is the gamma benzene hexachloride, that is also known as lindane, that we are using as a ectoparasiticide. Next is the organic phosphate insecticide, that is the organophosphorus insecticide. This organophosphorus insecticide example are dichlorophos, comaphos, chlorpyrifos, then cythioate, then the malathion. So these are the important drug are the organic or organic phosphate insecticide or organophosphorus insecticide. So this is important. Agar next insecticide group is the carbamate insecticide, and these examples are carbaryl and propoxur. So these carbaryl and propoxur are very much used insecticide from the carbamates group. Next is the pyrethroids. Regarding pyrethroids is concerned, this pyrethroid is example of pyrethroids is that we are actually mainly using in nowadays, very much in use, like the mosquito repellent. So in most of the mosquito repellent, this pyrethroid is coming under the example. They poses like methrin, like suffix like permethrin, cypermethrin, deltamethrin, flumethrin, then others elithrin. So these are the pyrethroid. And here I am going to mention this number one, that is the organophosphorus insecticide, and number number two and number three insecticide, that is organophosphorus insecticide as well as the carbamate insecticide. Both are possessing quite similar mechanism of toxicity against the protozoa, that is the not protozoa, against the parasite, ectoparasite. Both possessing the same type of mechanism of action. They both are we are going to discuss in detail. So both are inhibitor of an enzyme, we call it acetylcholine esterase enzyme inhibitor. So organophosphorus insecticide as well as the carbamate insecticide, the mechanism of action against the parasite is inhibiting one enzyme, we are calling it the acetylcholine esterase enzyme. So this one is inhibiting the acetylcholine esterase enzyme. Only difference between these OPI and carbamate insecticide mechanism of action is that both the drug, one is a irreversible binding with the enzyme, that is particularly with the organophosphorus insecticide, whereas irreversible type of binding with reversible type of binding with the carbamate, whereas the irreversible type of binding with the organophosphorus insecticide. So what is the function of this enzyme, that we are going to discuss in detail in mechanism of action. Regarding number 1 and number 4 is concerned, both are also possessing quite same mechanism of action against the susceptible ectoparasite. They both are acting on the sodium channel. Particularly pyrethroid is acting on the voltage sensitive, voltage gated sodium channel. Voltage gated sodium channel. So both are possessing the same mechanism of action. I mean the organochlorine as well as the pyrethroid, whereas the second pyrethroid as well as the some of the organochlorine also, in addition to this action on the sodium channel, they are also acting on the GABA receptor, both the drug also block the GABA receptor. So neurotransmitter GABA is not going to attach to produce its action. So they both are the GABA inhibitor. I mean, some of the drug belongs to organochlorine and also the type 2 pyrethroid. So this is all about the next is the macrocyclic lactone. We already discussed in the enthalamintic. So in this the drug are group are ivermectin and melvomycin. Under the ivermectin, the most usable drug is ivermectin. Regarding its mechanism of action of this is concerned, for both the group ivermectin and melvomycin, they are acting on they are blocking the glutamate gated chloride channel. So both are acting to block the glutamate gated chloride channel. So they are acting on the glutamate gated chloride channel. Insecticides. So both are acting on the in the mechanism of action we have to go in detail. So this is about the macrocyclic lactone. Now next is the chloronicotinil or neonicotinil nicotinoid insecticide, and the example is the drug is which is a derivative of nicotine. So therefore it is acting on the N-acetylcholine receptor. The mechanism of action is it is acting on the cholinergic transmitter by acting through the N-acetylcholine receptor, nicotinic acetylcholine receptor, because the drug is the derivative of nicotine. So the drug is imidacloprid. And the under that we are going to discuss is formamidines. So under the formamidines, the drug is Amitara. Amitara is usually contraindicated to use in horse, dog, and cats, and its mechanism of action is inhibiting the enzyme that is one enzyme monoamine oxidase, and also going to act on the another receptor that we are going to discuss in the mechanism of action in the detail. Insect growth modifier, there are groups that we are not going to discuss. Regarding natural insecticide is concerned, that is all we are knowing about the nicotine, rotinone, garlic oil, pyrethrum, then azadirachtin, that is the neem, that is the neem constituent, then curcumamine, then desmolene. So these all are the natural insecticide, and the last one under this is the insect attractor, that is the trichosine. So this is all about the classification of the drug that use as a ectoparasiticides drug. Now we have to go through the one by one in detail. So let us start the first one, the organochlorine insecticide mechanism of action. Regarding organochlorine mechanism of action, we already discussed. The regarding the example, we already discussed. We are going to discuss mainly about the methoxychlor and also about the gamma BSC gamma, that is benzene hexachloride BSC, and that is also called linden. In this organochlorine we are going to discuss about these two. And the important about the organochlorine is that we are not very much using this group organochlorine because of its three activity, that is the not degradable very easily. So this one is the non-biodegradable in nature. Second one is the because of the non-biodegradable nature, they are persisting in the environment. So environmental persistence is there, and once they persist in the environment, it get accumulated. So it activity get biomagnified. So because of that, the mercury type of activity may be seen. So therefore this type of activity that is why the drug group is not in use, and because of that this is going to produce health hazard to human and animals and birds also. Under that we are going to discuss only that we already mentioned methoxychlor and gamma benzene hexachloride we are going to discuss. So the first one is the about the organochlorine is a lipophilic, that means easily absorbed, and because of this of the activity with the mechanism of action associated with the sodium channel that is present in the neuron and some other places, then it will leads to the nervous poisoning or act as a CNS stimulant. So as we know that when this get entered in the parasite, ectoparasite, it will as we know in the neurons, that is in the particularly in the motor nerve, what we have to see that communication is occurring. So if this is a motor neuron, this is the motor neuron, sodium ion is entering and potassium ion is moving out. So sodium entering, then sodium ion is entering and potassium is moving out, like this way is going on. And because of this activity, depolarization, repolarization, depolarization, repolarization occur, and generation of action potential occur, and message will convey from one place to another place. So this entry of the sodium is through the sodium channel, and this sodium channel, through sodium channel, the sodium is entered inside the neuron, and therefore it produces the depolarization, or the depolarization, or you can say the excitability. So what will happen, what the drug this organochlorine will do, organochlorine attached to the prolong the this organochlorine insecticide prolong the depolarization phase. So when this depolarization phase prolong, it will produce, in depolarization phase is the phase of excitability. So it will produce the overexcitability. And when this depolarization phase prolong, the next cycle, that is the efflux of potassium ion, efflux of potassium ion get delayed, because when this sodium ion get prolonged, then the entry of the potassium ion is get delayed. So this activity occur, first one. In addition to this mechanism of action prolonging the depolarization phase by delaying the closure of sodium channel, so sodium channel will get delayed to close, and therefore it produces the depolarization, which is leads to overexcitability, and therefore efflux of potassium ion get delayed. And in addition to this activity, this group drug also possessing its action on GABA receptor. So organochlorine is going to bind with the GABA receptor. So with this receptor, one neurotransmitter is attaching. We are calling it the GABA. And the GABA, as we know, is inhibitory neurotransmitter to produce inhibitory effect. So when the space of GABA on the GABA receptor is occupied by organochlorine, so GABA will not attach to its receptor to produce inhibitory effect, so it will produce the excitatory effect, and therefore the parasite get died. So its activity that through the sodium channel, and the prolong inhibition the opening of potassium channel. This is first, and the second one is through the GABA. In addition to that, a small concentration of this organochlorine also depress mitochondrial respiration. And at high concentration, this organochlorine going to rupture lies the mitochondrial membrane. And as we know, in within the mitochondria, mitochondrial respiration is going on, so it will uncouple the oxidative phosphorylation, which is a pathway of ATP generation, and therefore blockage of electron system. So finally, at high concentration, it will lead to produce, it will hinder the aerobic respiration, and respiration, but not anaerobic respiration. It will affect the respiration because the mitochondria get ruptured, get lysed, then there is a uncoupling of oxidative phosphorylation occur, and therefore the ATP generation will influence it. So less ATP get generation. So this is very, very important. Regarding side effect of organochlorine is concerned, that we have seen, that is blockage of neurons. So this is blockage of the that is delaying of the closing of the sodium channel, delaying of the closing of the sodium channel. Therefore, it will influence the nervous system function. So this is the important, which leads to hypersensitivity, apprehension, restlessness, incoordination, moving in circle, abnormal posture, striking against the obstacle. So first drug under that we are going to discuss under the organochlorine is the gamma BSC or lindane. And about this age concern, the gamma BSC that we use in the animal like the dog, then we have to may use for cattle, sheep, goat, swine and horses. And this gamma BSC may be used as a spray, as a dip, as a dust to control the ectoparasite like ticks, fleas, lice. This is particularly for the dog. And as a spray we are using particularly for the species like cattle, sheep, goat, swine and horses, that we have to spray it as a dusting powder of benzene, gamma benzene hexachloride gamma BSC, that the concentration is about 0.2 to 0.5%. In bath it is concentration is 0.2%. As a dip and spray it contains 0.2 to 0.05% of the linden. So this is all about the gamma BSC. And the next is the methoxychlor. What is important about the methoxychlor? Methoxychlor is the DDT analog. And as we mentioned, this is also used against the ectoparasite like the flea, like the ticks, to control this in the dog. And this is in the form of spray and the dust. And this may be one of the ingredient found in the insecticide preparation. The methoxychlor concentration is about 0.5% to control the external parasite in the species like swine, sheep, goats. So this is all about the organochlorine, that is the methoxychlor and gamma benzene hexachloride. Next is the organophosphorus insecticide that we already mentioned. Regarding what is important regarding this organophosphorus insecticide is concerned, organophosphorus insecticide toxicity is more acute than the organochlorine and pyrethroid, but its biodegradable is more. So that is why we are still using the organophosphorus insecticide. But the problem with this organophosphorus insecticide is that their binding with the enzyme target acetylcholinesterase is irreversible. That is why this is going to create the problem. So under the organophosphorus insecticide, this when going to produce its effect through muscarinic receptor. How? Through acetylcholine. So when acetylcholine is attached to the muscarinic receptor, when attached to the nicotinic receptor, when it is in the CNS, they are going to produce several symptoms like in how this is going to produce organophosphorus insecticide activity. As we already mentioned, the neurotransmitter is acetylcholine, and acetylcholine activity get degenerated by breaking it in the component like choline and one more component. And this breaking down of acetylcholine activity within the body of the host is with the help of the acetylcholinesterase enzyme. So acetylcholinesterase enzyme, what this is going to do, this is degrading the activity of the neurotransmitter acetylcholine. So what the organophosphorus insecticide is going to do, organophosphorus insecticide is going to bind with the acetylcholinesterase, particularly with the stereotic site of acetylcholinesterase. So therefore acetylcholinesterase is not available to break the acetylcholine into choline. So acetylcholine get accumulated, and therefore when the acetylcholine is accumulated within the body of the patient, then the symptom of the acetylcholine will appear after its attachment with the muscarinic receptor, nicotinic receptor, or in the CNS. So acetylcholine, when attached to the muscarinic receptor, it produces salivation, lacrimation, bronchial secretion, vomition. When it is attached to the nicotinic receptor, the muscle tremor, respiratory paralysis, and when the central symptom is the excitation, ataxia, seizures, and meiosis. This is going to produce by the organophosphorus insecticide toxicity to the host. So as we already discussed about the mechanism of action of the drug, that is irreversible inhibitor of acetylcholine esterase, and therefore it leads to muscular paralysis of the ectoparasite. And as we already mentioned, this organophosphorus insecticide is going to bind with the acetylcholine esterase enzyme at stereotic site. So stereotic site is the binding site present on the enzyme acetylcholine esterase to with organophosphorus is binding, and therefore it inhibiting to the action of the enzyme acetylcholine esterase. The prodrug that is not active as such, they get metabolized within the liver, and therefore it get converted into active metabolite. So prodrug malathion and demphylate, and one drug is parathion. So malathion, parathion, demphylate is the prodrug. They have to convert into active component in the liver. So this is about the organophosphorus insecticide. The drug under this organophosphorus insecticide are chlorpyrifos. So chlorpyrifos that we are also using as ectoparasites in the form of spray, shampoo, dips, collar that we are going to put in the neck region of the dog or the cat, ear tag for the control of the ectoparasites like flea, ticks, lice, mites, and some more external parasite in the domestic animal. And also this all helps to use for the ectoparasite termites. Not termites is against use this chlorpyrifos. This is very toxic. Chlorpyrifos is the very toxic to the fish and amphibian. So this is very important. Next is the dichlorophos. Regarding dichlorophos is concerned, the dichlorophos percentage that we use as a spray is 1%, and this is 1% dichlorophos is used to control the ectoparasite fleas, lice, mites, ticks in cattle, and also in the other species. And dichlorophos orally used, as we know that, for the anthelmintic. So this is about the dichlorophos. Next drug is the cythioate. This is also an organophosphorus insecticide that we are going to discuss. So cythioate, their percentage is 1.6% as a liquid, and also as a tablet 30 to 90 mg tablet we are using to control the flea, ectoparasite in dog of all age, and also the ectoparasite ticks we have to use, and so demodectic against the demodectic mange. So demodectic mange against the flea. Not demodectic mange. Cythioate, the dose for flea in dog is 3 mg per kg body weight orally, and for next drug is dimpilate. Dimpilate is also biotransferred to diazoxine, and this metabolite of dimpilate is more active than the main component dimpilate. Regarding its use is concerned, as a ectoparasite, used as a ear tag to control the ectoparasite fleas in cattle, also used to control flea and tick as a collar for dog and cat, also as a spray or dip at percentage 0.025 percentage. Next is the ethione. This is also used as a ethione is also used as a ectoparasite. So this is used as a ear tag. We have to give this drug as a ear tag in the cattle against the ectoparasite horn flies, face flies, lice, tick, and mites, and the percentage for the topical concentration is the 0.075%. Next is the Fen Theon. and malathion. Regarding malathion, that we already mentioned, this is a prodrug and that get metabolized in the liver to convert into the active metabolite, and then the active metabolite of malathion is going to produce the activity against the ectoparasite. Another one that we already mentioned about the prodrug is malathion, then parathion, and that one more drug is there called the dimpilate. So dimpilate we already, this is also prodrug. Dimpilate is a also prodrug. So this malathion is one of the very much usable drug, and as a ectoparasites, and this preparation is coming in the form of dips for the dips and a spray, and the solution percentage is 0.5% solution for topical application in the species like cattle, horse, sheep, goats, swine, dog, and cats. So this is about the malathion, and the last one is the Fen Theon. This is also to be used to control ectoparasites in the form of ear tag, and also control the grubs of the cattle. So this is very important. And next group is as insecticide is the carbamate. So as we already mentioned about the carbamate examples are carbaryl, propoxur, and bendiacarb. Regarding this carbaryl and propoxy is concerned, this is very much in use. And regarding mechanism of action is concerned, that we already mentioned, carbamate insecticide is a reversible inhibitor of enzyme acetylcholine esterase. So this is important. So here I am going to mention one very important thing, that if the toxicity occur in the host, particularly for organophosphorus insecticide, as an antidote to the animal, host animal, we have to give the two drug, that one is atropine sulfate, another is the 2-palm, also called predlidoxim, also called oxime. But for because this is irreversible, so because of irreversible, we are giving the oxime, or that is called predlidoxim and 2-palm, to regenerate the enzyme, because this is irreversible. Whereas in case of carbamate, the reaction, the bonding between the enzyme acetylcholinesterase and carbamate is a reversible one. So the drug is going to relieve the enzyme by own self. So there is no need to give the drug to detach the carbamate and the acetylcholinesterase. For that, we have to give only one drug, atropine sulfate, as an antidote to treat the host animal, because if the toxicity will occur. So this is about the carbamate. In that we already mentioned about the carbaryl and propoxir. So carbaryl is one of the constituent that found in various formulation used as ectoparasites, like ticks, preparation, like fleas, like mites, like lice, for the species of dogs and cats. So what I am telling, in if you go through the preparation that we are going to use for the ectoparasite control, then you will not find only one constituent as ectoparasiticides. Many constituent is present. So that is why this one of the component is also there, carbaryl, and this carbaryl, other property about the carbaryl is that is to be given for the species in dog and cat, and this in the preparation, that is for the dog and cat, shampoo is coming, the powder is coming, the spray is coming, dust in collar and ear tag form, the drug is coming in this form to for the dog and cats. And carbaryl is usually used 0.5% for the application on the skin, and in the dog collar we are going to use as a 5% carbaryl. Propoxir, so another drug that belongs to the carbamate is the propoxir, and that propoxir is used against the ectoparasite flea and takes as a collars, that we have to use as a collar, as also as a spray for the the animals like dog and cat, and Propoxin 10% constituent for dog and cat as a collars. We are going to use as a 10% constituent of Propoxin. Next is the parathyroids. About the parathyroid that we earlier mentioned, that is the group that many components are coming as a mosquito repellent. And the mechanism of action is concerned that we already mentioned regarding mechanism of action of the parathyroid against the susceptible ectoparasite is concerned, acting on again sodium channel, quite similar to the organochlorine insecticide. So, but here this is acting on the VGSC, that is voltage gated sodium channel. So, its action is quite similar to the organochlorine. So, this is acting on voltage gated sodium channel. So, it is prolonging the entry of the sodium in the neuron, and therefore automatically it outward efflux of potassium get delayed, get suppressed. So therefore, because of the prolonging entry of the or prolonging inflow of the sodium ion is occurring through the voltage gated sodium channel, it is going to produce the depolarization, which resulted in repetitive discharge, membrane depolarization, and death of the parasite will occur. So this is important. And in addition to that, similar to organochlorine, particularly type 2 pyrethroid is also acting the same way. So pyrethroid is going to occupy the GABA receptor. So GABA will not find the space to attach there with the GABA receptor. So therefore, inhibitory neurotransmitter GABA will not produce its inhibitory activity through the GABA receptor. So excitation will occur in the animal and the animal will die. I mean, the ectoparasite will die, not an animal. Ectoparasite will die. Regarding the side effect and adverse effect of parathyroid is concerned, minimal effect on the host. So this is very, very important one. Regarding other property of the this is concerned, so the natural pyrethrin means this is mixture of about 6 natural insecticidal ester, pyrethrin 1 and 2, then cinarins 1 and 2, then jasmolene 1 and 2. So this is the natural pyrethroid is the mixture of about 6 natural insecticidal ester. This pyrethrin is going to produce synergistic action with the other drug like piperonil butoxide, piperonil cyclones, and sesame. So pyrethroid, when we are using with any of these, then this is going to produce the synergistic activity. So that is why pyrethrin as 0.1 to 0.2% used in combination with 0.5 to 1% piperonyl butoxide against the ectoparasite in form of spray, foam, dust, shampoo, dip, ear tag against the ectoparasite flea, lice, ticks, mites in dog and or cat, as a spray against flea and lice in horses. Now next one is the elethrine. This is the very important is that this is the first commercially synthetic pyrethroid. So this is important and used as in the form of shampoo to control the flea and ticks in dog and cat. Next is the permethrin. Regarding permethrin is concerned, this is also used as ectoparasiticide to the animal in the form of collars, that is collar on the neck region, then spray, we have to spray on the animal bodies because the ectoparasite is on the on the surface of the skin. Then dips, we have to dip the animal in the dip. So ear tag, we have to use as a ear tag. Then shampoo in the form of shampoo, and topical concentrate to control the ectoparasite that we earlier also mentioned: fleas, lice, ticks, flies, mites in domestic animal. Regarding its concentration as a spray is 0.025%. To control the tick. To control the flies, the percentage is 0.1% for control of flies as in livestock. In ear tag for cattle, the percentage is 10.5%. And the dusting powder, the percentage in shampoo is the 1% concentration. So this is about the permethrin. Next is the cypermethrin. Cypermethrin that we are going to discuss. Cypermethrin that we are also going to use as a ear tags for control of flies, ectoparasite flies, ticks in cattle, and often used in combination with chlorpyrifos. This is the organophosphorus insecticide. Cypermethrin used as a spray as a percent 0.1% for horses, 0.05% for poultry. And the pour on, we are going to pour on the body surface, then in the horses, cattle, sheep, goat, and in poultry as a ectoparasites. 0.015% for control of ticks. This is about the cypermethrin. Regarding deltamethrin is concerned, for the deltamethrin, this deltamethrin, the common name is also called decamethrin, and extensively used because this is a broad spectrum. So this is extensively used deltamethrin as a ectoparasite in the farm and in the companion animal to control the ectoparasites: flies, lice, ticks, fleas, mites. And the preparation is coming in the form of this teltamethrin used in the form of dips, spray, wash, pour on, spot on. Spot on means ki a particular spot is covering, where in case of pour on is this is covering the larger area over the skin. Then as a dermal spray or wash, the concentration is 0.0125 to 1% in dog, whereas a 1% solution as pour on in cattle, and the volume should be 10 ml. For sheep and pig, volume should be 5 ml. Deltamethrin is not used for collar in dogs. So this is all about the pyrethroids. Next is the macrocyclic lactones. Under the macrocyclic lactone, there are two groups that we already mentioned: ivermectin, we already mentioned in enthymolic also, and melbamycin. Under this one, very much usable drug is ivermectin as a ectoparasite. So this is very important. From the melbamycin, the drug are moxidectin, melbamycin, melbamycin oxime. So other drug from ivermectin is abamectin, doramectin, selamectin. Regarding its mechanism of action, that we already mentioned in the early, that is similar to the anthelmintic. So how this drug is acting? This drug is going to bind with the parasite in the parasite presence of glutamate gated chloride channel receptor. So when it get bind with this glutamate gated chloride channel in the ectoparasite, then it will open the chloride channel. Because of its binding to this glutamate gated chloride channel, it binding open the chloride channel, and therefore chloride ion get influx. So when chloride ion get influx in the nerve cell, then it produce the hyperpolarization and the paralysis of the parasite, and death will occur. And in case of tick particularly, in addition to paralysis, this also going to lead one more additional anti-parasitic ectoparasitic activity is activity on the reproductive cycle. So this is very disruption of the reproductive cycle of the ticks. Regarding its that we have to discuss, the first one is the ivermectin. So ivermectin is used against the ectoparasite, mites, lice, grubs, hornflies. Abamectin is to be used for the ectoparasite mice, lice, same, warble fly larvae in cattle. Next, doramectin is a broad spectrum, and this is used to control mites, lice, horn flies, warble flies larvae in cattle, mites, and lice in pig. So this is about the doramectin. Eprinomectin is used for the ectoparasite lice, mange, mites, cattle grubs, horn flies, and marketed only in the power-on formulation for the cattle. So likewise, the other drug that we are, so the last two drug is left, two group is left that we are going to discuss. The first one is the chloronicotinil or neonicotinoid insecticide, and the drug is imidacloprid. So in about the imidacloprid is concerned. So as we know, imidacloprid is the derivative of nicotine. So as we know, nicotine activity is going to produce by attachment with the nicotinic acetylcholine receptor. So because imidacloprid is also derivative of the nicotine, so it will also produce the same effect the nicotine is producing. So this is a broad spectrum activity and use against the insect pests and non-toxic to the vertebrate. So mechanism of action that we already discussed, similar to the nicotine, this imidacloprid is also bind with the nicotine acetylcholine receptor, and therefore it on the postsynaptic membrane. So therefore it interfere or it hinder the cholinergic transmission in the insect, which leads to paralysis and death. Again, I'm going to repeat the same thing. This imidacloprid is a derivative of nicotine, so it produces similar to action with the nicotine. So it bind with the nicotine acetylcholine receptor, and therefore it will interfere in the cholinergic neurotransmission in insect, which lead to paralysis and death of the in the ectoparasite. Regarding treatment of use against the ectoparasite is blia infestation in a small animal, and the dose for imidacloprid for the dog is as a spot on. It is percentage is 0.4 to 2.5 ml of 10% solution. For cats, also a spot on 0.4 to 0.8 ml of 10% solution, depend on the body weight of the animal. Now we have to go through the next group is the formamidines. Regarding formamidine is concerned, this is very important, and the drug is the amitara. This is very much used or may drug against the ectoparasite. And important point with amitraj is that this is rather contraindicated to use in the species like horses, cat, and dogs in heat stress. And its mechanism of action is concerned. Amitraj mechanism of action against the susceptible ectoparasite is concerned. It primarily or mainly act on one receptor. We call it the octapamine receptor. Why we call it the octapamine receptor? Because this particular receptor first identified in the octopus. So this receptor, and once this amitraj get acting on the octopamine receptor, therefore it activating the enzyme adenyl cyclase system. So when it get activated adenyl cyclase enzyme, and therefore this is going to convert the, this will resulted in the increased nervous activity. And in addition to the action on octapamine receptor, it also inhibits one enzyme. We call it monoamine oxidase. So on this enzyme, amitraj is going to inhibit, that is monoamine oxidase. And this amitraj is also producing idiosyncratic reaction or individual reaction that is seen in one breed of drug, that is the C. huas breed is a breed of dog. Its use is concerned, Amitraj use is concerned, that we are going to use as a ectoparasite against the lice, mite, ticks in cattle, and lice and ticks in sheep. Also, used against the ectoparasite, that is the lice and mite in pig, and demodex and sarcoptic mange in dog. And this drug that we already earlier mentioned, contraindicated in horse, cat, dogs in heat stress, and should not be used to treat puppies of less than 12 weeks of age, oblique pregnant or lactating bitches. Amitara's dosage is concerned, the dose is here, that we have to see the dosage. And so this is all about today class.